Slide 1. Today we thoroughly analyze the collapse of the ABF monopoly and the packaging revolution of 2026. The paradigm shift from plastic film to glass and light. For decades, the world of semiconductor package substrates has been dominated by a single material. That is Ajinomoto buildup film, commonly known as ABF. However, now, due to the explosive demands of next-generation technologies like AI and 6G, the foundation of this absolute king is shaking. In 2026, the market will face a historic turning point towards two frontiers: photosensitive materials and glass substrates. In this tectonic shift, how will Ajinomoto Fine Techno move? And what winning opportunities exist for Japanese companies like Taiyo Inc. MFG and Sekisui Chemical? I will unravel the back end. Material war that investors are overlooking with dense original analysis. Slide 2. Why ABF is hitting the wall. Physical limits. First, why is the long-beloved ABF being called limited? The biggest reason lies in the processing method. Current ABF substrates have holes vias drilled one by one using lasers. However, with the increasing scale of AI chips, the number of necessary holes is increasing exponentially to millions or hundreds of millions. Drilling holes one by one with a laser takes too much time and the cost doesn't justify it. Furthermore, there is the problem of skin effect, the natural enemy of high-speed communication. ABF needs to have a rough surface to ensure copper plating adhesion, but this roughness interferes with high-frequency signals and reduces communication speed. And then, the problem of warpage due to huge packages. ABF, being plastic, expands and contracts easily, with heat causing warping and connection failures when loaded with huge chips. These three walls of productivity, signal loss and warpage, are cornering the king. Slide 3, Frontier 1. The shift to photosensitive materials. The first technology to break through this wall is the shift to photoimageable dielectrics, or PID. This is a revolution that fundamentally changes how substrates are made. It converts from the traditional drilling with laser method to the imprinting with light lithography method, same as semiconductor manufacturing. Using photosensitive materials, hundreds of millions of holes can be formed instantly, and simultaneously just by shining light through a photomask. Whether the number of holes is 10,000 or 100 million, the processing time remains the same. Furthermore, it can create ultrafine holes of 2 to 5 microns in diameter, which is impossible with lasers, realizing wiring density approaching that of silicon interposers. Slide 4, the challenger Taiyo Inc. MFG. So offensive. The company moving most aggressively in this new market is Taiyo Inc. MFG. They are the world's top company for solder resist that covers the surface of printed circuit boards. But they are applying that technology to steal the inside of the substrate interlayer. Insulation market dominated by ABF. Taiyo Inc.'s strength lies in its technological capabilities through a partnership with the world-renowned research institute IMEC in Belgium. The dry film photosensitive material they developed demonstrated the ability to form extremely fine wiring of 1.6 microns. Moreover, since existing laminating equipment can be used as is, it has the strategic advantage of having a low barrier to entry for substrate manufacturers. A battle of the lower overthrowing the higher, where the king of the surface invades. The king of the inside is beginning. Slide 5, the defender. Ajinomoto. Fine Techno's evolution. Of course, the king, Ajinomoto Fine Techno, is not staying silent. Their strategy is defense through self-transformation. They are launching photosensitive ABF, which adds photosensitive functions to existing ABF to keep customers locked in. The clever point of this strategy is the inheritance of reliability data. For semiconductor manufacturers, switching materials is a huge risk. However, if they can change only the processing method to light, while maintaining the characteristics of the familiar ABF, such as thermal expansion coefficient, there is nothing more reassuring. Ajinomoto is not afraid to cannibalize its own products, and is trying to build a bridge to the next generation. Slide 6, Frontier 2, the glass substrate revolution. And the other, more disruptive transformation is glass substrates. This means a complete departure from plastic substrates. Why glass? The reasons are stiffness and flatness. Glass is several times harder than plastic and hardly deforms even when heated. Since its thermal expansion coefficient can be adjusted to match silicon chips, warpage does not occur even when loaded with huge AI chips. Furthermore, since the surface is flat like a mirror, ultra-high-definition circuits can be drawn, and electrical signal loss is minimized. Intel is a pioneer in this field, and plans to introduce glass substrate products between 2026 and 2030. Samsung Electromechanics is also partnering with Japan's Sumitomo Chemical to target this huge market with a Japan-Korea alliance. Slide 7, the hidden enabler, Sekisui Chemical. In this glass substrate revolution, there is a Japanese company that will be an absolutely essential stagehand. It is Sekisui Chemical. Glass substrates have a fatal weakness. They are fragile. When transporting and processing thin glass in a factory, if even a slight shock is applied, the whole thing will break. Sekisui Chemical's special tape called Selfa solves this problem. It holds the glass firmly during processing, and when finished, it peels off easily just by shining light. Without this magic-like tape, mass production of glass substrates is impossible. Sekisui Chemical is building an indispensable position by controlling the infrastructure for handling glass rather than making the glass itself. Slide 8. The equipment shift resurgence of Nikon and Canon. The change in materials also redraws the power map of equipment manufacturers. Instead of laser processing machines, which have been the main players, lithography, equipment steppers will return to the leading role. This is because high-precision exposure is necessary to draw circuits on photosensitive materials and glass substrates. Here, Nikon and Canon are facing a special demand. Orders are surging for back-end specific exposure equipment, which is not as expensive as cutting-edge front-end machines, but has a deep depth of focus, capable of handling substrate distortion. The material shift is bringing an unprecedented capital investment. Supercycle to Japanese camera makers. Slide 9. Supply chain bifurcation and geopolitics. This technological transition also carries geopolitical implications. Currently, the supply chain for ABF substrates is concentrated in Taiwan and China, but glass substrates are seen as a good opportunity to reset this. Absolix, a subsidiary of Korea's SKC, has built the world's first glass substrate factory in Georgia, USA. Amid the China Plus One movement, moves to disperse next generation, packaging bases to the US and Japan are accelerating. The supply chain transforms from a single route to a complex network, involving Japan, the US, and Korea. Slide 10. Conclusion: bifurcating winners. In conclusion, from 2026 onwards, the world of packaging materials will enter an era of technological bifurcation, tailored to applications, moving away from the ABF dominance. In the short to medium term, photosensitive materials from companies like Taiyo Inc. MFG will encroach on the high-end market, and in the long term, glass substrates supported by Sekisui Chemical and others will become the standard for AI and high-performance computing. And regardless of which material wins, lithography, equipment from Nikon and Canon will definitely be needed. Investors should look not for one universal material, but for companies with process technology that supports this differentiation for each application. The end of a monopoly is also the beginning of the birth of new winners.